All right, let's dive right in. Today we're talking about how computers learn to see. And I mean really see, like being able to recognize your dog in a photo. So think about this. What if you could teach a computer to pick out your dog, but without writing a single rule? I mean, no long list of if it has floppy ears and a wagging tail. None of that. What if you could just show it pictures, let it figure out the patterns on its own? It sounds kind of like magic, doesn't it? But believe it or not, that's the fundamental idea behind how modern AI sees the world. The best way to wrap your head around this is to just think about how a little kid learns. You don't hand a toddler a textbook with a list of rules for what makes a dog, right? You just show them pictures, you point at the park and say, look, a doggy, over and over. You show them big dogs, small dogs, fluffy ones, and after seeing enough examples, something just clicks in their brain. Eventually, they just know. Well, it turns out we can use that exact same principle to teach a machine. So how do we actually build a digital version of that toddler's learning brain? Well, we look for inspiration in the real thing, our own biology. And that leads us to something called a neural network. The name kind of gives it away, doesn't it? It's a system of algorithms that's loosely modeled after the way our own brain's neurons connect and fire. Its whole job is to do one thing, and do it exceptionally well: recognize patterns. So if you look under the hood, a neural network is made up of layers. You've got an input layer that takes in the raw data, like all the pixels in an image. Then you have these hidden layers. This is where the real thinking happens, where it starts piecing the patterns together. And finally, you've got an output layer that makes the decision, that says, yep, that's a dog. So what makes a network smart? It really comes down to two key things: weights and biases. Think of weights like tiny little volume knobs on all the connections. They can turn a signal way up or turn it way down, telling the network what's important. Then you have biases, which are kind of like a little nudge that shifts the signal. Together, these are the knobs the network gets to tune to get smarter. Okay, so the network has all these digital knobs to turn, but how does it actually learn which way to turn them? Well, just like our toddler, it starts from a place of knowing absolutely nothing. A brand new neural network is a complete blank slate. All those little knobs are just set to random values. So its first attempt at identifying a dog is really just a wild guess. The entire learning process is simply about getting better and better at guessing by learning from its mistakes. And it all happens in this simple three-step loop. First, the network makes a guess. Maybe it says, I think that's a cat. Second, we check the answer. Since we already know the picture is a dog, we can tell the network how wrong it was. Third, and this is the most important part, it learns from that mistake. It goes back and slightly adjusts all those internal knobs to make a better guess next time. And it does this again and again, thousands of times. This whole feedback mechanism, where the error gets sent backward through the network to update everything, has a technical name: backpropagation. It's the fundamental algorithm that lets the network learn from experience, slowly refining its guesses until they become incredibly accurate. This all sounds great in theory, but does it actually work? Let's look at a classic example to see just how powerful this can be: the ultimate internet showdown, cats versus dogs. So researchers took a neural network and just fed it a massive data set of images, some labeled cat, others dog. The network went through that learning loop we just talked about, making guesses, checking errors, and adjusting its knobs over and over. Nobody told it what a whisker was. It had to discover those patterns all on its own. And the results? After all that training, the model could look at a brand new picture it had never seen before and correctly tell if it was a cat or a dog with about 95% accuracy. That's incredible. It just goes to show how effective this method of learning from examples really is. And of course, this isn't just for fun with pets. This exact same technique is the engine behind so much of the technology we use every day. From automatically detecting faces in your photos, to your email filtering out spam, to your bank flagging a suspicious charge, it's all powered by neural networks that learned from examples. So let's bring this all home. Because this powerful technology isn't just sitting in some far-off research lab. It's right here in your pocket, and you probably use it dozens of times a day. Every time you use a piece of smart technology, you're likely interacting with a system that was trained just like this. It learned not from a set of rules, but from an enormous amount of data, figuring out the patterns all by itself. In fact, it's exactly how your phone recognizes your face every single morning. The next time you unlock your phone, just remember what's happening. A tiny neural network is processing the patterns of your face and making a split-second decision. It wasn't programmed with the rules of what you look like. It learned them from examples, just like a child learns to recognize a dog.